Hello everyone, I'm going to walk you through the results and observations I experienced, where I explored the concept of electric charge using common materials like Scotch tape. The purpose of the experiment was to investigate the behavior of charged objects, particularly how excess charges on two pieces of tape interact, and to estimate the amount of charge present on one of the tapes. By understanding these interactions, we can draw conclusions about the nature of electrical forces and how they balance other forces, such as gravity. The overarching result of the experiment is that tape, when properly charged, exhibit repulsion or attraction depending on the charge on the objects it interacts with. This simple experiment allows us to estimate the excess charge on a piece of tape, demonstrating how everyday materials can acquire a measurable electric charge. The first step in the experiment was to create charged tapes, referred to as U-tapes. I took two pieces of clear tapes, stuck one on top of the other, and then peeled the top one off quickly. This method removed electrons from one of the tapes, leaving it with a net positive charge. Moving on to the first observation, when I brought my finger close to the hanging U-tape, it was immediately attracted to my hand. This attraction indicated that the tape was charged, and based on my prior knowledge, I expected two U-tapes similarly charged to repel each other when brought close. Next, I made a second U-tape. As expected, when I brought the two U-tapes together, they did repel each other due to having the same type of charge. This is in line with Coulomb's law, which states that like charges repel. Additionally, each tape was attracted to neutral objects, such as a box, because neutral objects are polarizable and can shift charges internally to create attraction. To determine whether the U-tape was positively or negatively charged, I used a plastic pen rubbed with a cotton towel, which gave it a negative charge. When I brought the negatively charged pen near the U-tape, the tape was attracted to the pen. This confirmed that the U-tape was positively charged because opposite charges attract. The second part of the experiment involved balancing the gravitational and electrical forces acting on a piece of tape, referred to as tape B. When tape B floated above another charged tape, it indicated that the upward electrical force from the other tape was equal in magnitude to the downward gravitational force. This balance allows us to calculate the amount of excess charge on the tape. First, I calculated the gravitational force acting upon tape B. Then, once the force is known, I use the distance between the tapes, approximately 0.095 meters, and Coulomb's law to estimate the electrical force. Electrical force is equal to K times Q squared all over D squared. By setting the gravitational force equal to the electrical force and solving for Q, the charge on the tape, I calculated the magnitude of the charge on one piece of tape to be approximately 1.8 times 10 to the 9th C coulombs. To reach the result, I had to make several assumptions and approximations in the computational model. I treated the long piece of tape as though it were a point charge, with all the charge concentrated at its center. I assumed that each tape I made had about the same charge, evenly distributed along the length of tape. I ignored air resistance acting on the tape, which could have affected its motion during the balancing process. These assumptions simplify the problem, making it possible to calculate the charge despite the complexity of the actual system. In conclusion, the experiment gave us a clear understanding of the behavior of charged objects and allowed us to estimate the excess charge on a piece of tape. The U-tapes repelled each other when brought close, confirming that they were similarly charged, and their interactions with other objects helped determine the nature of their charge. Mathematically, we saw how the electrical forces between two charged tapes can balance the gravitational force, allowing one to float above the other. While the calculations provided a reasonable estimate of the excess charge, there were some potential sources of error in the experiment. For example, environmental factors like humidity may have affected how well the tapes held their charge, and inaccuracies in measuring the mass of the tape or the separation distance could have introduced slight errors in the final charge calculation. Overall, this experiment successfully demonstrated the concepts of electrostatics and gave us practical experience with balancing forces in real-world scenarios. Thanks for watching the video, and I hope this helps breakdown helps you better understand how charged objects behave.